I'm pleased to welcome Elliot Abrams from AccuWeather today.
This looks like a gym class that I go to where everybody stands in the back. So if people would move up a little bit or over this way, it might help out since I talk too soft. Is there any room at this table or anything for anybody else?
Yes, feel free to come on up if you'd like.
Everyone is frightened. All right. Anyway, the briefing is going to be toward the end of this. I'm going to actually give part of a presentation I gave at the AMS conference, and it was about fake science and how to get people to believe that science is real, which is a big challenge today. How many of you believe that it is a challenge today? How many think it's not a challenge today? How many don't know? How many don't care? How many won't answer regardless of the choice? Well, I think everybody said yes. Anyway, first of all, one thing is, can lightning strike the same spot twice? And is this proof that it actually can? No, it's not, because I didn't play the slide correctly. Down here, and you'll see that it looks like lightning is hitting the same spot multiple times. But all that is the exact same 3-second long video spliced together multiple times to make it look that way. It's the exact same lightning strike right there, and there it's over. But today with video and pictures and things like that in Photoshop, it's very easy to make things look like something that they weren't. So how do we get around that? Well, that's a case where that's so unlikely to happen, and you can see the clouds move a little bit in between the shots, so you can easily disprove that is real. Then we have the scientific method. It starts with developing a hypothesis and then a prediction about something, testing it out, doing an analysis, and other components. And an important key in there is replication. But is replication something that we do in the science of meteorology and atmospheric science? Not particularly. Very hard to get the whole atmosphere to do something and then replicate it. And even getting the models to be reliable so that if they're supposed to predict a 30% chance of something, they really do that, that's a big challenge. And so maybe the scientific method needs to be adjusted in terms of that term there. Because some people will say, if you can't replicate it, it's not science. And that's not really true. Of course, then there are beliefs and warnings. If you're on a golf course and somebody yells 4, chances are somebody will cover their heads. What I asked my friends to do here, believing that there was actually something happening, and then one didn't believe it any longer and took his hands off his head. But what happens with a tornado warning? Many times people will walk outside and look to see if it's really coming. So doing what you're supposed to with the warning. So sometimes you need another person running to a shelter to believe that you should run to the shelter. These sociologists sometimes say that. I'll show you this. Here is this an example of climate change. This is January of 2017. Last year, Barrow, Alaska, the temperature is running 30 degrees above average for 8 days. Is that climate change? Or is this climate change? Barrow, Alaska, the following month where it was 20 degrees, somewhat close to the long-term average. Or is this Boston, Massachusetts, averaging 10 to 20 degrees below average in January of this year? Another example of weather changes. Gray areas, how consistent is a certain weather regime with climate change? Why or why not does that matter? I won't answer. But what to do? Well, some deniers have an agenda if they're backing from certain energy interests. It's believed. One article claiming this was written in 2014, and it blamed Peabody Energy for giving a big grant, but actually that company declared bankruptcy that year. And also an important thing is they feel their opponents are beating them over the head about it. Why don't you believe this? You're stupid. And that just makes people who believe certain things more resistant to change. Somehow you have to convince people in a more logical way or with a little better persuasion that they should maybe look at things a little more deeply. Some people just have a certain, they know that certain things right, and it's sort of like tunnel vision. Everything funnels into that one belief. Turning to astronomy, how many of you have seen a comet in the past year? Neither have I, and so as a public service, I actually made a picture of a comet over a coastline. And I mean, who can deny that that's a comet over a coastline right there? Very clean picture there. But we can use simple concepts to increase trust in science. This building, for example, why is it standing here? Why isn't it collapsing? Somebody guessed that we needed a certain type of material to get this to stand up and to hold up? Or was there engineering science that went into it? Things in the kitchen. If the container says its capacity is 4 ounces, why should you trust that? Well, it's made according to a standard. Airplane travel, computers, how farm equipment works. All these things are examples of the use of science. A lot of people don't even realize that that's actually what is being followed. Risk. If fewer than 10% of the climate scientists do not believe in human-related climate change, where is your safest bet, the lottery or the scientists? Problem. We say we believe it, but what we do is this my problem or is it someone else's problem? Even if we believe that something's happening, should we be the ones that solve it? If we decide to do something, what's the best approach? Who decides? Who does the work? How can we tell if the solution is working? Sadly, 90% of us are not in the top 10% of the best scientists in this room. Isn't that scary? Of course, 85% of us know that we're above average drivers, so that's all right. Other sciences have the same problem. Cancer spread, for example. Recent research indicated that cancer can spread along nerves rather than through the body in other ways. That few people have studied that, and that's why they haven't made as much progress as they should have curing cancer. Recent weeks of food additive has been found to blame for the C. difficile epidemic that has become rampant since 1995. Baylor University, they did a study and found that this particular type of sugar that had not been economical to produce until 1995 was probably to blame. And that sugar actually, when it gets into your gut, helps to foster this particular bacteria and make its effects even more serious than they would otherwise be. And so I talked about the culprit in there. So all these things are important. And then we see in literature, in many magazines like Science and Nature, articles have to be retracted because it turned out to be fake science being presented. But still, we have the scientific consensus that Earth's climate is warming, as on this graph. Scientific organizations all believe it, such as these. And what about our nationalities? The U.S. is the lower left portion of this chart of people that have believed that there's a human influence in climate change. Of course, any graph like this, you have to look at the lowest value and the high value. I mean, it looks like it's 0 down there in the lower left, but actually that's just a portion of the spectrum, so not quite as bad as it might seem if you had a graph going from 0 to some maximum number. But climate change denial is most prevalent in the U.S. and least prevalent in countries like France and India. There's an organization called the Citizens Climate Lobby. There's a branch in State College of this. And their idea is a tax that would be collected on carbon, and then there'd be an equalizing distribution to people so that there'd be a net of 0. It wouldn't be that people would wind up losing money permanently. So how will climate change over the next 50 to 100 years? How many scientific predictions that were made 100 years ago have actually come true today? I don't know the answer to that, but many ideas change over time. So some will argue that even if we are changing the climate, which I'm virtually certain we are, as I think how many of you believe that idea, that we're doing that? How many think at least it's 50-50 if that's true? Okay, well, But some people will say, even so, are the people that found that out the same people who are going to solve the problem? Maybe a different branch of science and engineering that actually solves these problems. And then there are things like atmospheric rivers. I didn't learn about these when I was taking undergraduate courses many years ago, but there's one of them sitting there on a satellite picture. They're now attributed to forgiving 30 or 40% of the total rainfall in some areas. And we have such things as extreme events occurring. And then there are 10 and 100-year floods. What do we do about that? Well, if the amount of intense rainfall and frequency of severe rainfall is increasing, why do we use the same engineering tables that were developed 5, 10, 15, 20 years ago? We're always using past tables to design our waterways and stormwater catchment. We're always going to be behind. It's actually true with flood forecasting and river forecasting. I think it was during Agnes in 1972 that the practice changed from using only previous rainfall to estimating future rainfall in terms of what it would do to river stages. If you had a 2 or 3 day long storm, you couldn't use 1 day storm statistics or 24-hour storms. Storms don't really go by the clock like we want. Here we'll get to today then. One other thing that I believe is fake science. A friend of mine, Joe Gastardi, who just published a book called Climate Chronicles: Inconvenient Revelations You Won't Hear from Al Gore and Others. I'm going to go through this and make notations to myself of where I think there are problems, but which I'm certain I'm going to find, in my opinion. Anyhow, was this morning's map looking at the pressure analysis. There was a lead cold front coming across Ohio, and they're just beginning of a wind shift. It's a very gradual wind shift there. The isobars don't really curve that much, but they sort of start to curve where I drew the line. It might be a little farther east than that. And then there's the real Arctic air behind that second front. You look at the temperatures, for example, drops to 45 in Cincinnati to 31 at Chicago. This was 7 this morning, Eastern time, and then 12 in Madison and 5 at La Crosse, Wisconsin. It's a big drop in temperature behind that second front, and those Hyperborean winds straight from the remote frozen hinterlands of the Arctic. The place where a woman or man must go prepared or not go at all, a land locked in snow and ice the year round, a land, in fact, where the tender tundra is all too quickly covered by the first snows of September, never to be seen again until the following June, a land better known as Bradford. That's where the air is coming from. And here it was at 11 a.m. The first front was farther across Ohio, and the second one barreling to northwest Ohio and having already crossed Michigan. So that's coming late tonight. So what's going to happen? Typically around here and along the eastern seaboard, a front like this will be fairly dry ahead of it unless there's been a long time for Gulf moisture to get involved. And today we see the cloudiness. We saw a little bit of light snow yesterday afternoon as the Arctic air departed. But since then, there's been virtually nothing. And in the southwesterly flow, there isn't much precipitation. The front will probably get just enough moist that there'll be a few showers with it. But what about behind the system? Will there be any snow? Usually around here, there isn't. There will be some in western Pennsylvania, downwind from the Great Lakes. But here and along the East Coast, there usually isn't. But we'll check the models anyway, and one that has been particularly good recently on some of the snowfall that has occurred has been the 3K NAM. And it shows, this was for 5 p.m. today, an area of rain in the Ohio Valley and some snow across southern Ohio and just light snow showers across western PA and into western New York. Nothing odd there. But if we go into the night, it changes character. And when you look at the jet structure and where the moisture seems to be coming from, so the snow does appear to break out behind the front, the blue area that you see there in east central Pennsylvania and in West Virginia. And at 6 o'clock tomorrow morning, it's still affecting areas of New Jersey to New York City and to Boston. So if this is right, it will turn colder and there will be some snow behind it. The impact of that's very important because we had a couple of showers and then the temperature dropped. So what? Most streets would dry out and there wouldn't be any problem. But if there's some rain afterwards, the streets will at first become wet, and then as they freeze, ice forms, and then snow falls on top of it. And even if you get only half an inch to an inch, people don't know how to drive every time they see new snow. And this would come right at the rush hour tomorrow. If it came at midnight tomorrow night, it would be no big deal. Everybody would be asleep or coming home from parties, and they might not care. But the 7 or 8 o'clock tomorrow morning, as this suggests, would be a big problem along the I-95 corridor. So we'll see if this works out. Did pretty well a few days ago with the snow that wound up getting to New York City and Boston, when some of the models that a couple of days before indicated nothing would get there, would skip over them. And we look at the jet structure. To me, this doesn't really look perfect for tomorrow morning because at 12Z, we're sort of in the right front quadrant of the jet at 250 millibars, and that would not be an area where you expect much to be happening. But shortly thereafter, 6 hours later, you could argue we're getting to the right rear quadrants across southern Pennsylvania, but this is getting a little bit late. This is for 18Z tomorrow, when most of us would think that the whole thing would be passed. But if the jet can move quickly enough that it's to our east, and I don't think all the models came up with the exact same solution here, but if we were in the right rear quadrant, that'd be a good sign that something was going to be happening behind the front. A couple of old style tools that I like to look at in the office are the 200 millibar chart. This is probably the most absurd forecasting rule that I've ever heard about. That if you take the temperature difference from the warmest reading at the bottom of the trough at 200, and the troughs are warm there, to the coldest reading downstream, you draw a line from the warmest place to the coldest place, and take the difference between the values and divide by 2, that's how many inches of snow you'll get from the storm. Now you think about that, how can you use something at 200 millibars, a metric unit, divide by 2 and get inches of snow? Well, it's coincidental, but it actually is a good regulator of one's forecasting. If we saw a huge spread across there, which we don't, there's a minus 55 here in eastern Nebraska, and minus 54 in central Michigan. There's some minus 60s in the bottom of the trough in Missouri, and some minus 60s downstream in Pennsylvania. It's not a high snow producer. But that's another thing. If you think there's going to be a lot of snow, and I use it this way, if in advance I think the storm might be productive in terms of snow, but I do not see a big spread in the temperature on this chart, I think that I get the idea that I'm wrong. It's not going to be that big. If maybe I don't think it's not going to be that important a snowfall, but I see a huge spread across there, then I get worried that it is going to snow a lot. And the whole thing is, why should there be a big temperature difference? In the bottom of the trough, if the air is sinking dramatically, then that will make it warmer there. And if the air is rising rapidly downstream from there, there will be a much colder reading. And so if you have a huge coupling there, a huge difference in temperature, that's an idea that you have a big upward motion field or a downward motion field associated with that trough. And one other tool that is helpful sometimes is the 1,850 thickness line. Sometimes we tend to look at what's presented to us, that we use say the 543 or 540 line for the snow versus rain decision using the 5,500 millibar thickness. But if you use that whole depth, kind of throwing away some information, because it's almost always below freezing up near 500 millibars, even 600 millibars in the wintertime, or 700. But it's the ground, the lowest 5,000 feet, that often makes the determination between snow and rain. And so if you have a measure that correlates well with that, the 1,300 line does very well on this. And I drew a little sketch of where that was from northern Kansas up into central New York. So people thought, okay, well, if it's cold this morning, maybe it's going to snow. As soon as I saw this, I thought to myself, it can't. It's just too warm. Maybe there'd be some freezing rain or sleet if it got in before the ground got warm, but there wasn't going to be any snow. These are a couple of old style tools. And of course, the greatest old style tool is the one that comes out of its burrow tomorrow morning. I think it's making a big mistake, however. Look how cold it's going to be tomorrow morning. This poor critter's going to come out. Freezing winds and everything. And you can't see its shadow anyway. Having been there at this induction to the Weather Person Hall of Fame a few years ago, I turned around and looked at the time when they brought the groundhog out to see if you could see the sun at that time, the blue sky. You cannot, because there's a hill in the way. There's a small hill that sits with the east-southeast of the viewing stand, and so it's really impossible to see the sun at sunrise. I think they typically will make the decision 3 minutes before actual sunrise at 7:23. And the real reason for that, I think, is because on all the national TV shows, the local news comes on at 7:25, and they wouldn't have any viewers then. But at 7:23, great time for a story. But I don't think this is a fake at all. Every time that the groundhog has come out, and whether it's seen a shadow or not, every year we've had spring after that. Can anyone deny that? Spring, it comes at different times, but we've always had springtime. So this is a great forecasting tool that this year too, we will have spring. I have no idea where it'll be. One other tool that's interesting, it was first time I saw it written about was in a 2001 edition of Science magazine. It was called the anomalous flow in the high stratosphere as a harbinger of cold air discharges. And the idea was that if you looked at the 10 millibar chart, that when the vortex there broke down or split or migrated away from the pole, that could be a sign of cold air. You still had to determine where the cold air would be, where it would go. But the thing that's been most classic on it is when there's a split, and the vortex separates completely and reverses to a high, that you're looking at a blocking pattern developing a week to 10 days. But then you read that if this pattern develops, it may last for a couple of months. And I've always wondered why that should be, because suppose the vortex closes back up again a couple of weeks later, why shouldn't that be a signal that that pattern's going to end? Yet, people have done statistical research, it doesn't really end that fast. The GFS model for this particular level, 10 millibars, actually predicts a complete split of the vortex in about 2 weeks. I haven't looked at that prog that often for that, although I think that it's predicted that a number of times when it hasn't happened, so we'll see. I like to go to the University of Wyoming site. They have a weather web there, and you get these charts whenever you want, these 10 millibar charts or any chart, then you can plot them immediately on a polar map base. It might not be readily available. So, it's not that cold this afternoon. We have a southwesterly flow. Maybe there'll be some showers. Then as we go through, the cold front will come through, start getting chillier. And then later tonight, the cold air will even pour in faster. When we wake up tomorrow morning, there'll be face freezing winds straight from jail or January or Portland's February. Cold winds that we'd like to send back where they came from. We might blame it on Canada, but they blame it on Alaska. And Alaska would blame it on Siberia. You would be right. But it's going to be very cold and blustery tomorrow. And at the tail end of the showers tonight, maybe there's a little bit of snow. And what I'll tell people then is you might want to think of waking up 10, 20 minutes early tomorrow morning if you're a radio listener. And then if nothing happens, you just realize, boy, I woke up 10 or 20 minutes early. I'm going to listen to this station for an extra 10 or 20 minutes every day by waking up early. And the stations love it when I tell them that, but of course it's all nonsense. I'd rather sleep longer. Any questions on the little briefing?
Were you following the snow situation in Long Island the other day when I think the forecast was for like 1 or 2 inches and some areas got up to 7 or 8 inches?
Well, I know in the morning we'd gone for 5 or 6 inches of snow there, more in eastern Long Island. In fact, the day before we thought that, but it blew up more than we thought. And I think Rhode Island had the greatest departure. We had 3 to 6 inches the day before for South Shore, South Coast area around Boston. I did notice that the jet structure changed as the storm moved in. It's sort of like this effect here, where nothing happened here. We had a little bit of light snow. The system from the west died out, and then it re-strengthened on the east coast. But it was very erratic across parts of Michigan. There were some places that got 7, 8, 9 inches of snow. In other places, 30, 40 miles away, got very low. Did you find anything other than that?
I wasn't really following much.
But it did, there certainly was much more snow in those areas. And in the forecasting issue, if you've made an impact that is going to be slippery, people will hear that. If you only tell the number of inches, you're really vulnerable because this snow is largely air. I mean, there's the air standing there right in front of you. A couple of tenths of an inch of water can mean the difference between 4, 5, 6 inches of snow. It's dry and powdery, and it's very easy to look bad predicting snow. But I'm not too up on this, but I know with the cloud physics, some of the snowflakes will form into like hexagonal plates, which slide across each other quite effectively and make the snow very slippery, where others that have a different structure will not do that. And I believe you can tell from the sounding which kinds of flakes are most likely to get. I don't always do that, but I know there are people that look for that specifically in our office to see how slippery this snow is likely to be, whether it's like graphite or some loose powder that isn't really a problem. Any other questions, issues, worries, consternation?
What are you thinking about Sunday?
The Sunday storm?
Yeah, or storm.
Well, it looked impressive for a couple of days, and the runs today seem to look weaker. Another one of these things that look like they're coming across the country, it'll cut somewhat northward. And so I'm not too excited about it. If it gets some extra moisture, then maybe we get a few inches of snow from it. One that I'm ready to monger for maybe is the one for next Wednesday, Thursday, and Friday. But maybe by next Monday or Tuesday, that too will fade into oblivion. I mean, there's no blocking. There's any storm that gets stronger, it's fairly likely to cut somewhat northward. That diminishes our chance of getting snow. And if it's a weak storm, why should it snow that much from that? Plus, it's an anapron type thing where you'll have snow on the north side of the front and it slowly slips out and maybe it stalls. So it's been an unexciting and unrewarding winter for predicting a lot of snow. Some of the people in our office think we're due for a big snowstorm, but the Eagles are due to win this weekend. Does that mean it'll happen? As a Philadelphia sports fan, I've learned not to get too confident until they're ahead by 2 touchdowns with 1 minute left. Anything else? No?
Any other questions for Elliot?
I forget if I told you the story about the pop farm. There's a pop farm in California. It has nothing to do with the weather. There's a pop farm there. They were growing this stuff. It's legal. Before they planted it, there were cattle all over the place. When they planted the seeds, the cattle all left. But when the plants matured, the cattle returned. And it was a clear case of the pot calling the cattle back. I have worse ones, but I'm out of time.
Any other questions for Elliot today? All right, let's give him a round of applause. And next week we'll have John Bang on. There you go.